Hello everyone, welcome to this new video where we are going to dive into maximum number of moves in a grid. So basically you have a grid, and in the grid you have valid move you are supposed to perform, and the valid move are actually from a given cell. You can either move to the cell, you can move to the next row, either to the element directly above you, the element directly in front of you, or the element directly down to you, which are like this. And a move is possible only if the value where you are moving toward is actually greater than what you were actually. What does that mean? That means if I'm here, I cannot actually, this is actually a move, possible move, but it's not valid. It's not valid because this value is actually less than this, but this is actually a valid move. It is valid because this value is actually greater than this. Now, given that condition, the problem here is to find out what is the longest path you can move starting from any of the elements of the first row. For me to solve this, I'm really going to use a straightforward approach. I'm going to use a recursion, which would be like, okay, I will just consider each of the elements as a sub problem. So I will say, starting from here, what is the longest path I can move? So I will say, okay, starting from here, I know I can move either here, or here. I will choose the valid option. I will compute those valid options until I found the longest path I can move starting from this position. And I will keep this answer. I will also compute this one, and I will keep the maximum of those two. I will compute this one, keep the maximum of those three, and compute this one, and at the end I will have the maximum I can have. So now, what will like an implementation look like? So like we said, the idea is this: get the longest path given the row, the column, and the value you have. So I know I will need to use the grid, but I don't want to pass the grid as a function while moving. So that's why I created the global variable, and I set the value of the global variable to the grid, so I can use it in here. So the idea is the following: whenever I want to compute the next part of a given element, I will check if it's already here. That means there's nothing I can do. I'll just need to return the value you were having. So if the column plus 1 is actually equal to the grid of 0.size equal to the number of column, then I return the value. There's nothing I can do. Otherwise, I have three options. What I just said, I have three options: up, sibling, and down. So I'll just create three options. I will initialize my option as the value. Why? Because if I'm actually here, moving here will give me a path of the path that I had moving here plus 1. So that is why while computing the path from here to the next one, I'm not initializing at 0, but I'm initializing at the path that it caused me to be here. So we are going like this. So we initialize it as val, and then now we have the option 1, which is actually moving up. The up is row minus 1, col plus 1, and val plus 1. And then this is actually sibling. That means we keep the same row, but we move one column forward and the value plus 1, because we are moving one step forward. And the last one is this one, where I'm moving row plus 1 and col plus 1. So that means we are moving down and value plus 1. And by doing so, at the end of this, you will have three options with three different values, and you just compute the maximum of those three, and then you return is actually the maximum of the path that you can have starting at this position. And then the idea here is to say, okay, now we'll look through all of the rows. For each of the rows, I will compute the path starting at the first element, and I will keep it to the result, and I will just have the maximum of the previous one and the current value until I have my solution. So let us run and see. It is working perfectly. Let us submit. Okay, we can see that despite performing pretty well, this is actually missing some test cases due to time limit exceeded. What can we do to make it pass those test cases, or what are even something we can optimize here? One thing you can see is that if I'm starting here and I move here, from here I will compute value that will be here, and after this I will be here. When I will be here, I will still have the possibility of moving here, and I will do the same thing. Whereas since I've already visited this guy, there's no need to visit it twice, because the cost of moving from an element to this, if it's already visited, is actually equal to the cost of moving of any of the possible element that will reach here. That means if 2 can lead me to this with a cost of 5, if 3 can also lead me to this, it will be the same cost. If 10 can lead me to this, it will be the same cost. So what we can do is that whenever we are visiting an element, we want to make sure that if we reach that element again, we just ignore it, because we know that the result we had previously while visiting that element will be the same result we will have if we try to visit it. So we just ignore it. So for us to do that, we can use a set. We don't want to use the answer, so there's no need for us to use a map that will give us the key and the value. We just want to use a set, just to say, okay, this element has been visited. And for me to use how will I put the key? The key for me will be, since I know the maximum value of m and n is actually this, I'll just have something that will be I would say the concatenation of the row and the column. So that's why I'm times this and plus column. So it will just be like a concatenation. And yeah, by doing so, you are making sure that you are not visiting element twice. And with this, we still have everything passing properly. And let us submit again. Yeah, we can see that it's working properly. So this is my approach of solving this. I hope you do enjoy. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new video. Ciao.